Today we are looking at the application. We are looking at the application of integration. Application of integration. So we're basically going to solve just a couple of questions here, where we are going to look at concepts like the area of a region, volume of a solid, and also we're looking at the centroid of a area bounded by certain graphs. So we are going to start with the area. So just with the first question, it says find the area of the region in the first quadrant enclosed by the x-axis, the line y is equals to x, and the circle x squared plus y squared is equals to 32. So here you are given these three graphs. They are intersecting, and while they're intersecting, they form a region. So we want to find the area of that region. So it's best to actually sketch this. So you have the Cartesian plane. We are just looking at the first quadrant. So this is your x, y, this is 0. So we know the first graph, you have the x-axis, we already have the x-axis. And then the second graph is y is equals to x. So we just have this line here, y, which is y is equals to x. And then we have an equation of a circle. The equation of a circle with its origin at the center. The equation of a circle with its origin at the center and the radius of 30, which means 32 is equals to r squared, which means r is equals to root 32. So that's the radius of a circle. So we're just going to have, I'm just going to draw, it's just a sector of the circle. This is the sector of the circle. We are looking at the first quadrant. So I'm just drawing the first, this is the graph. This is x squared plus y squared is equals to 32. This is y, and then also we have the x-axis. So we are looking at the region that is bounded by all of these three lines. So that region is what? This is the region that is bounded by all of these three lines. This is the region. So we want to find the area of this region. So how do you find the area of this region? Obviously, you are going to use integration. But before we go there, we need to find, since we are going to use integration, we need to find the limit of our integrals. So they intersect at this point, right? So we need to find A and B. Once we find A and B, we'll be able to find this area. We just need to find the intersecting points at A and B. So basically, how A, obviously it's a given because A is the origin, so it's 0, 0. And then what about B? We can see that the equation of the circle intersects the x-axis at point B, right? Which means if it intersects the x-axis at point B, the value of y is what? Is 0. So here we are going to make y 0. So we're going to say x squared plus 0 is equals to 32. And we can also see that here we just get the radius of the circle, which is root 32. So this point B, it's root 32, 0. So now I can find the area bounded by these three lines. So the area, remember, is equals to alpha, beta of the, if depending on the functions, if you have f of x plus f of 2x, right, plus can be as many area functions as you can have. So here you're going to have since we have A and B and they are bounded by these by this function. So we are going to say this function, the upper function, we're going to say it's the upper function, which is y is equals to x, right? Plus, or we can just separate it like this, where you can get these points here. This intersection is called C. So you just find these. I think that will be the easiest one to find this triangle. Let's find C. So C, what is C? C is going to be, okay, let's start with finding C. C, it's the intersection between the equation of the circle and the line y is equals to x. So where there is y in the equation of the circle, we are going to substitute x because they're intersecting. So we are going to have x squared plus y squared is equals to 32, right? And we are going to substitute y is equals to x. So we're going to have x squared. The reason why I'm substituting x because we're looking for the x value here. We're looking for this x value. So this is going to be x squared is equals to 32. So 2x squared is equals to 32. So now x squared is equals to what? So 32 is it's 16, right? So x is equals to plus or minus 4. But we are looking at x is equals to 4 because of it's in the first quadrant, which is we're looking at the positive value of 4, which means this is 4, right? So from here, we are going to, how do you find the area then? The area of, so we are going to find the area of this, we're going to find the area of this triangle. We know the dimensions, right? So, okay, if we also need to find the y value to sort of like find the height of the triangle. What is the y value? If x is positive 4, what is y? So 4 squared plus y squared is equals to 32. So y squared is equals to 32 minus 4 squared. So y squared is basically 32 minus 8, right? So now we are going to have, if it's 32 minus 8, or 32 minus 16, I'm sorry, which is like basically 16, and then y is equals to what? We know that the root of 16 is still plus or minus 4, but we are looking at this 4, right? Which means now the area of the triangle, the area of the shaded region is the area of the triangle that we formulated, right? Plus the area of this triangle, or you could just say the area of the line y is equals to x between 0 and 4, either way. And then this portion is plus the integral, since it's a curve, since this is a curve, the integral from 4 to root 32, the integral from 4 to root 32 of what? Of the equation of the circle, x squared plus y squared, right? Sorry, I could have just goes with respect to x, so you make x the substitute of the formula. So y is equals to root 32 minus x squared, right? So here x squared, root 32 minus x squared dx. So this is basically the area of the area of this graph. So let me just try to redraw it so that you guys can see. So I said, so basically we have so this is the line passes. So it passes the origin, right? And then we have the this is the equation of the circle, and obviously the x-axis. So we are looking at this region, but with that region you can split that region into this small triangle and this curve, in this small curve. So you can integrate the curve and then just use arithmetic for the triangle. Or if you don't want to use that, you can just say, since we are looking at this line up until to this point where it's 4, and then this point which we called B was root 32 0 from, so you can just say you're finding the area from 0 to 4 of what y is equals to x of x dx plus the area from 4 to root 32 of what, of 32 minus x squared dx. You can use like this, or you can use this way. Either way, it doesn't matter. The reason why I'm showing the geometric aspect of this problem is because you can tackle this problem in different ways. So if you integrate this, you will find the area of this region. So you can just easily integrate that and then substitute your values. Okay, so that's how you can approach the first question. So now let me take another one from a different, let me see, still we have polynomials. Okay, let me try number 2. So number 2, they are saying, find the area of the region bounded by the two parabolas y is equals to x squared and x is equals to y squared. So okay, so you can kind of also draw the a parabola is going to be like this. So y is equals to x squared, and then it's going to be like this. If you're looking at y, it's root x, which is the same thing as y squared is equals to x, right? So so we are looking at this region. We are looking at this region. So we need to find this intersection point, which I'm going to call A, and then this is the origin, right? So what is this intersection point? So this intersection point, we can find it by equating these two graph, which means x squared is equals to root x, right? That means x to the power 4 is equals to x, and x to the power 4 minus x is equals to 0. And from here, which means we can just solve this, let p be equals to x squared. That means we have, okay, x to the power 4, or just to make it simple, okay, let me just make it simple. This is x cubed minus 1 is equals to 0. So x is equals to 0, x is equals to 1. So here, this is positive 1. So now to find this region, what are you going to do to find this area? So it's going to be the area of the graph on top minus the one on bottom. So you're going to have, the area is going to be the integral from 0 to 1 of root x minus x squared dx. So here you can find the area. So basically this will be integration, when you integrate root x is going to be what? It's going to be x 3 over 2, 2 over 3 minus x cubed over 3, and then you have 1 0. You just substitute here, which means you're going to, if you start with 1 and then 0, which means you're going to get 2 over 3 minus 1 over 3 is equals to 1 over 3. So this is your entire area. So that was question 2. Let me take a last one for the area. Let me take this one, since it's trigonometry. So with the trigonometric graphs, find the area bounded by the curve y is equals to cos x between x is equals to 0 and x is equals to 2 pi. So again here, you need to sort of like sketch to see which regions are you looking at, because the cos graph is like this. So this is from 0, this is from 2 pi, right? We are looking from 0 to 2 pi. So we are looking at this region. So we're basically looking at these regions, right? But you cannot just integrate, because if you integrate, if you're saying your area is equals to the integral of 0 to 2 pi, or this is, by the way, this is y is equals to cos of x. That's what they say, that if you integrate this cos of x, you're going to get that you get sine of x, right? If you decide to do this, and then 2 pi to 0, that will be 0 minus 0, right? Which is equals to 0. But you can't tell me that this area is 0, so that's wrong. So how do you do this one? You're going to first of all integrate from 0 to this point, and we know that this is what? This is pi over 2, right? And then from pi over 2, you're going to integrate to 3 pi over 2, which is 270. Then from 3 pi over 2, you integrate to 2 pi. So you're going to have your area split into 3. And the first part is going to be the integral from 0 to pi over 2 of cos x plus of cos x dx, I keep on forgetting this, plus the integral from pi over 2 to 3 pi over 2 to 3 pi over 2. But now you can see that the value of this side, this part of the graph, is on the negative part of your graph. So it's on the negative part of your y-axis. So which means it's negative cos x, right, dx. And then again, that part is going to be plus the integral from 3 pi over 2. I'm looking at this area now, this area. So to 2 pi cos x dx. So this is how you find the area of your graph for this trigonometric function. So here you can easily substitute. This is going to be sine x pi over 2 0 plus, if you integrate, okay, it's going to, let's fix out the minus. It's going to be minus, if you integrate cos, it's going to be sine x 3 pi over 2 plus cos is going to be sine x, and then 2 pi 3 pi over 2. So if you substitute here, sine pi is what? Sine pi over 2. Sine pi over 2 is 1. So it's 1, and then minus sine 0 is what? Is 0. Minus, and then coming back here, you have sine 3 pi over 2. So if you have sine 3 pi over 2, it's going to be minus 1. So it's minus 1, and then sine pi over 2. Sine pi over 2, again, it's, you said it's 1, so minus 1, and then plus sine 3 pi over 2, it's minus 1, minus sine pi over 2 is 0, So this is going to be 1 minus minus, it's minus 2 plus 2, then this is plus minus, this is minus, let me see if I didn't make any mistakes while I was calculating this. Sine pi over 2 this is going to be 1, yes, and let me see, and then minus sine pi, this is positive 2, yes. Oh no, this is, I made a mistake here. This is going to be 1 minus 0. So this is plus 1. So this is equals to 4. So if you go about this, but you can just substitute this, you're going to get that your area is 4. But if you solved directly, you can see that you got 0, which is wrong. So you need to sector the graph and see which regions, especially when it's trigonometric, where there is cos or sine. You look at the domain that you're given. In our case, we're given from 0 to 2 pi. So you look at the regions that are affected by this domain, and then you sector your graph accordingly. So that's how you can find the area. So now let's look at the volume. So find the volume. I'm just going to take number 6. Find the volume of the solid generated by revolving the given boundary region about the x-axis. About the x-axis is very important. The region bounded by this graph and this graph. So again, you need to sketch. So let me try to create more space. Let me try to erase some of this so I can create more space. Okay, so we are trying to find the volume of revolution. So you need to remember the two formulas that we use when you're trying to find the volume of revolution. So here we are finding the volume of the solid generated by, okay, you draw, you sketch, you draw your Cartesian plane, and then we are saying y is equals to x squared plus 2. This one is, if this is 2, it's going to be like this. Y is equals to x squared plus 2. This is 2 here. And then if you sketch again, okay, let me just say this goes like, okay. And then if you sketch again, you have y is equals to x plus 4. So if maybe 4 is here, then this is minus, if this is minus 4, this is positive 4. So we are going to have a line passing like this, right? A line passing like this. So this graph also goes like this, isn't it? Because it's a quadratic, it also goes like this. So now you have these two intersection points that you need to, so you want to find the volume of this solid generated by this region. So find the volume of the solid generated by revolving the given bounded region about the x-axis, the region bounded by. So we're looking for the volume of this region A. So how do you find the volume? It says it is bounded about the x-axis, which means the volume is equals to alpha beta pi is about the x-axis, y squared dx. So that's how we find the formula that we're going to use, since it's about the x-axis. So now So we need to find alpha and beta, our limit. How do you find that? Those are the intersection points, so it means we equate the two graphs. So we are going to have x squared plus 2 is equals to x plus 4, x squared plus 2 is equals to x plus 4. So you just x squared minus x minus 2 is equals to 0. So you have, if you factor out, you're going to have x minus 2, x plus 1. If I'm not mistaken, x minus 2, x plus 1. So this time is, yes, this is equals to 0. So x is equals to 2 or x is equals to -1. So this point is going to be -1, which is also consistent with our sketch. This is 2, right? So now you can integrate, but then remember we have two graphs here and with respect to y. So how do you do this one? In order for you to find this area, you're going to say the upper graph, which is y is equals to x, the upper graph which is y is equals to x plus 4 minus the one below, which is y is equals to x squared plus 2. So your volume, let me write it here. So your volume is going to be the integral from -1 to 2, from -1 to 2 pi. So y squared, the first y squared is for the one above. So we know that y is equals to for the line y is equals to x plus 4, right? But what is y squared? We need to find y squared. So this is our y squared. So y squared here is x plus 4 squared minus, right, minus the one below, which is the parabola. So we know that the parabola is y is equals to x squared plus 2. What is y squared? So you square both sides. So even this is going to be x squared plus 2 squared, and then this is dx. So by this you are going to find the volume. So the volume is going to be the so I can just work this out directly. So this is going to be pi, and then if we integrate the first one, we are going to get x plus 4 cubed over 3 minus, if we integrate the second one, you have x squared plus 2 cubed over the derivative of what is inside, which is 2x times the new power. So 2x times 3, which is 6x, right? And then from 2 to -1. So your volume is going to be, if you start with 2, we are going to have, if you start with 2, so where there's x, you substitute 2, obviously. So 2 plus 6, 2 plus 4 is 6 cubed over 3. That's the first part, 6 cubed over 3. So we have 6 cubed over 3, which is 72. So 72, okay, let me just write the entire 72 minus, we are going to have 4 plus 2 cubed again, 4 plus 2 cubed over 6 times 2. So 72 minus 18. So for when you substitute when you substitute 2, you're going to get 54 minus, when you substitute -1 here, you're going to get -1, which 3 cubed over 3, it's 9, -1 there, 3. So you're going to have 3 cubed over 6 times -1. negative 9 over 2. So you have 3 over 3. This one is cubed minus answer. So you have 27 over 2. And then you can simplify this to find the volume. So basically what you do, when you're given a region bounded by two graphs, obviously you need to determine the intersection points, so that those are going to be your limit. So once you have determined the intersection point, and then you determine which graph are you going to, then you expand this formula, right? Because this is the integral from alpha to beta. This is pi of y squared 1 minus y2 squared, right? This basically means the first graph minus with the second graph. Since we have two graphs, you have the line and we have the curve. So that's how you solve this one. A volume of a solid generated by a revolving that given region about the x-axis. And then now let's look at another concept, the centroid. So with the centroid, I'm just going to take number 9. With the centroid, it says find the centroid of the area bounded by this curve and this curve, right? So that's it right there. Just find the centroid bounded by these two curves. So okay, from here you can basically see that you can sketch that again. You can also sketch that such that you have okay, even if you don't sketch it with the centroid, you can solve it directly, but you just need to know the formulas of finding the x value of your centroid coordinate. So let me just explain the concept of centroid again. So if you are talking about centroids, so we say you just say you have your graph, right? Your graph, and then you have two regions. This is A, this is B. So this is y is equal to f of x is a curve. So this is the area under the graph. This is the area A under the graph, right? So here we say we want to find the central position of this area. We want to find the central position of this area, and that central position we want to determine the coordinate of that central position. So how do you do that? Obviously you need to find the x value of that, right? You need to find the x value and also find the y value. So you need to find the x value of the centroid and the y value of the centroid. So the x value, you can get it by integrating x dA over integrating dA, right? And then the y value you can get doing the same thing, integral of y dA over the integral of dA. And then now, but we need, we can further expand these two formulas to simplify them. So if is equals to, so if I'm using the same graph, so now let me just clear this graph. So I'm using the same graph. I'm going to, so with the same graph, I'm going to just take a small script, just a small increment from this graph, a small increment of the area that I'm going to call dA, just a small increment of the area, with the width that I'm going to call dx, and then a height of y. So this is just a small rectangle. So we know that dA, since it's a rectangle, the area is equal to base times height, y times dx, right? So using this relationship that I've generated here, I can substitute with this dA, I substitute this in these two equations. So x bar is going to be the integral of x. Then when there's dA, I have what? Y dx over the integral of y dx, right? And then again with the y bar, this is the y bar is equals to the integral of y times y dx. So this is the same thing as y squared dx over the integral of y dx. So now these are the more convenient formulas that you're going to use. So coming back to our problem, so they are saying you are given let's say find the region, find the center of the area bounded by the curve y is equals to x squared, and so we have these two curves. Oops, where was I? Okay, we have these two curves, y is equals to x squared and y is equals to what? Y is equals to 8 minus x squared. Y is equals to 8 minus x squared. Right. So again, here we need to find the limit for this. We need to find the limit of our integrals, and the limit of our integrals is where these two curves intersect. So you're having x 8 minus 8 x squared is equals to x squared, right? So you have 2x squared is equals to 8, which means you have x squared is equals to 4. You have x is equals to plus or minus 2. So these are your limits. So if you want to find the x coordinates, so you're going to integrate from negative 2 to 2, integrating x. Where there is y, what do you substitute? So where there is y, you substitute, so you have, okay, y